Okay, so welcome to the screencast that I'm recording. Now, I haven't used QuickTime Player to do this before, so we'll see if it works well or not. I might stop after about 10 minutes so that if it's not working so well, then I haven't wasted too much time and we can try something else. But anyway, I've got open the email describing the problem, and you'll see that we've done a bit of back and forth already about what kind of metrics we should use, but I think we'll have a go and see if we can get something happening. Basically, I guess this could be interpreted a few different ways, but I'm not sure that it matters so much for the sake of the exercise. The way that I kind of interpret this is we're going to take like an existing kind of stack for building an API. We want to add kind of on top of that somewhere this kind of metric capability that we're going to return through a WebSocket, right? And maybe there could be other kind of ways that you might want to think about doing this, like maybe actually building it into a web server itself or something like that. But I think for the sake of brevity, what we'll do is we'll just put it maybe in the kind of middleware of a web stack around a little kind of API application. Since this is going to be demonstrating also some kind of Haskell development environment, what I might do is the following. I'll take a Scotty application. I know we spoke briefly about Scotty before, and that'll just serve up maybe some kind of trivial route like hello, and then maybe also some kind of compute heavy route, computing a big Fibonacci number or something like that. And then what I might do is rather than try and kind of interface with Scotty directly, what I'll try and do is build the metrics into the WAI layer as middleware. So it should be able to work with any WAI compatible application rather than just Scotty. And then finally, what I might do is actually think about which metrics we're exposing. Now, some ones that were mentioned in this mod status plugin that sound quite useful. Let's just have a quick look at the documentation for that. Yeah, so the number of like in-flight requests, idle workers status, total bytes served, then some kind of like system stats like CPU, things like that. Seems quite useful. We might not do all of that. We might just worry about at first like the current in-flight requests, and if I get that done okay, then what I might do is in the past I've used this kind of like monitoring package called EKG, and what that'll do is provide some kind of like runtime statistics, and maybe we'll see if we can expose them through the same API. I guess I'll have to build a little proof of concept Javascript app or something so that I can have a look at the data coming back from the WebSockets. I'm not really super familiar with WebSockets, so we'll kind of see how that goes, but I imagine doing it from JS is not too hard, I would hope. And that's going to be my approach, I think. So I've currently been recording for about 5 minutes, so maybe I'll just write up a couple of notes before we dive in. So I'll have a look at, let's just call it notes.txt. So we'll say here the problem restated as where are we? There we go. Restated as create statistics monitoring capability exposed in relation to a running API. Inspiration taken from mod status, and statistics served for consumption through WebSocket. I believe that's covers most of the part 1 anyway. Then the approach. I'll do this as, let me just turn down the music a bit. I'll do this as a WAI middleware over a Scotty application, which will serve an API that will have a fast route and a slow route. Maybe the fast one will be something like hello, the slow one will be something like a big Fibonacci number. And then I guess why not a third route as well, the stats route, where we can actually display the stats coming back from WebSocket. Okay, that just then leaves maybe some testing. So if this is all working, there should be like a few little kind of unit tests that we might be able to do, but I think like also probably what we'll want to do is write a little agent that hits all the API endpoints, and then we'll just have a look at the stats page while the agent is running. And if all goes well there, we should see our statistics updating in some kind of meaningful way. I guess in terms of the statistics, or the metrics, I guess what we'll do is going to be in-flight requests, maybe like requests per second in some form, and then if that is all done in a timely manner, then we'll have a look at some EKG system stats as well. Now I know that's kind of served up via a REST kind of interface, so maybe we can figure out what the kind of lower level packages that EKG users are and use them, or maybe EKG exposes a kind of more flexible way to interact with the statistics that it gathers, and so if that's the case we might be able to do that, but we'll have a look. Okay. Given that we're about 8 minutes, I might stop the recording now and just check if it's working. Fingers crossed. I'm not much of a screencaster, so this is all a little bit new, so we'll see how we go. I'll join you again soon if it's working.